Okay, so we're given a problem that's asking us to find the integral of cos to the 44 multiplied by sine x with a differential of dx. Looking at this problem, we can see that it's clearly an integrating problem, and its key attributes are the cosine raised to the power for 44 and the trig functions cosine and sine. So the way to solve this problem would be looking at the tools or techniques that we have to solve integrating problems. So these tools include analytical and numeric integration, which, as we know, is used for approximations and utilize Simpson's rule, trapezoid rule, and for this particular case we could use analytical and numerical integration, except it wouldn't be very practical or time efficient, and at the same time it's possible to get an exact answer, so we probably should get an exact answer from this integral. Another technique we could use would be improper integration. This technique implies singularities or regions that fly off to or explode to infinity or to minus infinity. And looking at the functions we have are cosine and sine, it seems like these functions are nice enough. Their domain does not explode to positive and negative infinity. In fact, we know that cosine and sine are bounded to 1 and a minus 1. So this technique probably isn't ideal, but let's look through the rest of our tools and see if we can find something better. How about integration by parts? Okay, with integration by parts, looking at this problem, it seems that we could probably get a reduction formula out of it, except that seems like it's time consuming, and a reduction formula isn't, or obtaining a reduction formula usually isn't the most time efficient way to solve a problem. It is for certain problems, but this problem, it seems like there's a better method that we could use. Another tool or technique that we have is inverse, trig, sub. And this we can obviously see from the expression above that there are no inverse trigs, so this technique isn't probably the best to use. So that leaves us with partial fraction expansion and just good old trigonometric substitution. Okay, with partial fraction expansion, it requires a radical, a rational expression, and it's under the integral we're given a trigonometric function, so partial fraction expansion would not really work in this case. So the last tool that we have is trigonometric substitution, and looking at this problem, it does seem like the ideal choice, but as we said before, analytical and numeric could possibly work, except we wouldn't get an appropriate answer. Integration by parts, we might be able to get away with getting a reduction formula to solve this integral. However, trigonometric substitution seems like the best choice to tackle this problem. Okay, so last video we were presented with this problem, finding the integral of cosine to the 44x multiplied by sine x with the differential of dx, and we went through the particular tools and techniques that we had to solve this problem, and we realized that trigonometric substitution was the best approach to tackle this problem. So with trigonometric substitution, we require a u substitution. Looking at this problem, it seems like we have two choices, one being u is equal to cosine x, and the other being u is equal to sine x. there's no way to know beforehand which way is the better way, but there always is a better way. And with practice and experience, you'll gain that confidence to integrate using your head and being able to find which one is the easier one before you actually go and start integrating. But for this particular question, let's just try both and see which one is easier. So let's start with u is equal to cosine x. So the first thing we should do is differentiate it to find out what our differential is in terms of du. So du in respect to dx will give us the derivative of cosine is minus sine x, and that implies that dx is equal to du over minus sine x. Okay, subbing that back into the original expression, we get the integral of u to the 44 multiplied by sine x. Our dx we already determined here was equal to du over minus sine x. Our signs conveniently cancel out, and we get minus the integral of u to the 44 du, which is just a reverse power rule, and gives us minus 1 over 45 u to the 45 plus a constant. And subbing it back in, we get minus 1 over 45. Our u is cosine to the 44x to the 45x plus a constant. Okay, so that way seemed pretty straightforward, and we got a nice answer. Now let's try using sine. So with sine, we would do the same thing. So find our du in respect to dx. And that would give us cosine x, implying dx is equal to du over cosine x. Now when we go to plug it back in, we'll see that we get the integral of cosine to the 44x multiplied by u times du over cosine x. One cosine cancels out, but we're still left with cosine to the 43 times du. So this expression wasn't really simplified that much, and it's not as convenient as using the substitution u is equal to cosine x. So that implies that our choice of u is equal to cosine x here was the correct choice, which gave us this nice answer. Alright, and that's it for this question. Thank you for viewing.